Hi, welcome to this lecture on mathematical methods for biologists. We have been learning about functions and how to deal with functions, and we learned differentiation, and in the last couple of lectures we started this we discussed this concept called integration. What does it essentially mean? It means that if we know the slope of a function, if we are given a slope of a function, can we get the function itself? So that's what we discussed in the last lecture. We started discussing in the last lecture or so, that given a slope, how can we start thinking about the function itself? So the title of today's topic is integration rules, and the question that we will answer in this lecture is, what are the standard rules one should know to integrate a function? If you want to integrate a function, which is then what are the standard rules one should know? So what we learned is that if we know the derivative of a function, can we say something about the nature of the function itself? And that is integration. And if we know the slope of a curve, this is the same thing in other words, is that if we know the slope of a curve, can we say something about the nature of the curve itself? So that is the fundamental basic question that we are answering, or that is what integration helps us to answer. And we said that integral is like an antiderivative. This is if you have dy by dx is m, where m is a constant and m is our slope, we can integrate this equation and get y. So known dy by dx, we can integrate and get y. That's what we can, and we saw that if dy by dx is m, we can write dy is equal to m dx. Integrate on both sides. Integral of dy is y. Integral of m dx is m is a constant, so I can take outside. Integral of dx is x and plus c, where c is an arbitrary constant. So this is something we learned. So there are some questions that might come to your mind. When we say that when we say integral dx is x, what does that mean? This is some question that we will answer. We will think about it. We will think about this later in the courses, but this is something you should know, the integral of dx. If you integrate dx, this is x. This essentially means that if you find, when you say integral dx, this is 1 times dx, and 1 is a constant, and integral of 1 is like x plus a constant, of course. So there is x plus integration of 1 is x plus a constant. So this is something we saw. Instead of 1, you could have 3, then you will get 3x plus a constant, and so on and so forth. Now in general we got y is equal to mx plus c, where c is an arbitrary constant and m was the slope. Now instead of a straight line, if we have a curve, if our slope itself was dependent on x, something that we have learned earlier, that for many functions, if we have x square, x cube as functions, we know that if our function is x square, we know that dy by dx is 2x. So now we could think of the opposite, the other way, that is, if we are given the slope m as m of x as 2x, can we get y? Right? If we are given m of x equal to 2x, what is y? In other words, we have y is equal to x square divided by 2. Y has a derivative 2x, and dy by dx, which is our m, will be 2x divided by 2, which will be x. In other words, we have the slope, which is, if we know the slope, which is x, we have to figure out that the integral of this is essentially x square by 2. The only thing is that we could have a constant here, some other constant, doesn't matter. Even if you have a x square by 2 plus a constant, the derivative of this would be x. So this is something that we know. If we think of our slope function, the slope function as x, if we integrate x, we should get x square divided by 2. Similarly, we know that if we had our function as x cube, if we had our function as x cubed, we know that dy by dx, which is our slope, which is m, which is 3x square. So we know that if this way, if we have m is equal to 3x square, the y is x cube. So this is something that we know. And so if I integrate m, which is the slope, I should get x cube plus a constant. Everything is up to a constant, because as we said in the last class, we cannot determine, if we add a constant, things don't change. So we can if we differentiate x cube, you will get 3x square, and if we integrate, we should get x cube. So in other words, if we think of y as x cube divided by 3, dy by dx would be our m. Our m would be x cube will have 3x square, and 3x square divided by 3. So in other words, m will be x square. So we have m, which is the slope, which is x square, and you have y, which is the function, which is x cube. So now we can go this way from here to here. That is, given the y, we can calculate dy by dx. So if y is x cube by 3, we know that dy by dx will be x square. The opposite, that is, if our slope is x square, the integral of this, the antiderivative, if you think of that way, it has to be x cube divided by 3. So if it is x square, x cube divided by 3, right? So if it is x, so let us write quickly some slope and the function. So we saw just now that if we have function y, if the function is x square divided by 2, the corresponding m will be x. And if we have the function x cube divided by 3, the slope will be x square. So this is something that we saw, that is, we can put an arrows like this. Here to here, this way, we are finding derivative, and here this is integral. Here we are finding derivative, and this way it is integral. So if I integrate x, I should get x square divided by 2. If I integrate x square, I should get x cube divided by 3. So since we already know that this is, what is the derivative of function, we can think of the inverse, the antiderivative, as the integral. Therefore this rule will emerge that if y is equal to x power n in general, dy will be, if we have dy by dx as x power n. So this is a mistake here, it should be read as dy by dx is x power n. So let me explain here. So if we have dy by dx as x power n, so if we have in general, so we saw this, that is, if we have dy by dx, that is our m, which is dy by dx. If this is x power n, and the y will be x power n plus 1 divided by n plus 1. So this is the rule. So this is, I can substitute here. I have x cube and then I have x power 4 by 4. I can have x square, then I can have x cube divided by 3. I can have x, then you have x square divided by 2. So this is the rule that we should know. That is, if we integrate this way, if we have a slope, if the slope is x power n, the function will be x power n plus 1 divided by n plus 1, where n is any number. So n could be like even 0.5. So this is the rule, that first rule that all of us should remember if we want to quickly do the integral. If you want to remember a rule, this is the rule to remember. One of the rules to remember, that if you have a integral, if the dy by dx is x power n, then x power n plus 1 by n plus 1. So in other words, this can be done in different ways. Now we can think of x power n plus, in the sense of x power n, we could have a constant. So let us take a different number. So let us take, instead of x square, let us take 3x square. So let us take, if we have a m, which is dy by dx, is, let us say, 2x square. Then I can write dy is equal to 2x square dx. I take dx this side. Then I integrate on both sides. So I will put an integral sign here. Integral, integrate. So integration of dy is y. Integral of 2x square. So I can take this 2 as a constant. The constant I can take outside. And then I can find the integral of x square, which is x cube divided by 3. And integral of dx is 1. And this is plus a constant. So in other words, if I have a constant times a function, I can take the constant outside and find the integral of this function. So this is my constant, which I keep as it is, and this is my function. So this was my constant 2, which I kept as it is, and this was my function x square, which will have an integral x cube by 3, and the function 2, the constant 2, will remain as it is. So you have 2x square, 2 will remain as it is, x square integral will be x cube divided by 3. So this is true in general for any constant x power n. So let us say instead of this, you have m, which is dy by dx, which is equal to k x power n in general. So k is a constant, x power n is my function, and y, so dy is k x power n dx. I put integrate on both sides. So here it is y is equal to, integral of dy is y, k times integral of x power n dx. So integral of x power n dx is x power n plus 1 divided by n plus 1 plus a constant. So this is in general, we could remember that k could be any constant, k could be half, k could be 2, k could be 7, k could be anything, and this is the formula to apply. If we apply this idea, we would get the integral of this function. Let us quickly do, taking k as a fraction. So let us apply this when, let us say we have m is equal to dy by dx is equal to let us say x square divided by 2. So our k is half is our k x square. If I integrate this, y will be half will remain as half itself. X square will have an integral x cube divided by 3. So the answer will be x cube divided by 6. So remember, if we have x square divided by 2, this 1 by 2 I could take as a constant k, keep the constant k as it is and integrate just this function x square, and we would get x cube divided by 6. So now we could directly apply this formula to many to calculate integral of many functions. Let us think about function that we learned, which is like in exponential function. So we learned that exponential function e power x can be written as 1 plus x square divided by 2 plus x cube divided by 6 plus an infinite series. If we calculate the integral of this, what is the integral of e power x? So integral of e power x would be, so let us say this e power x dx would be x plus x square divided by 2. So integral of 1 would be x. So let us take term by term, let us take each term by each term and integrate. So if we just take first this term 1, so let us do this quickly on the paper. So if I have e power x as 1 plus x square by 2 plus x cube by 6, which is 3 factorial plus dot dot dot. Now if I want to integrate this, I have to integrate on both sides, integral dx on both sides. Now because this was my function, if the answer of this is the integral of term by term, so integral of 1, so the first is integral 1 dx, that is the first term, plus integral second term x dx, plus next integral x square by 2 dx, plus integral x cube by 6 dx. So integral 1 dx is x, integral of 1 is x, integral of x dx is x square divided by 2. Integral of x square is x cube divided by 3 times 2, 6 plus dot 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 plus a constant. So this is my integral. If this is my m, if my m is e power x, this is my function y. If m is d power x, y is this. Now look at here. There is x here, there is x square. There is x square divided by 2 here, there is x square divided by 2. There is x cube divided by 6 there. There is x cube divided by 6 here. And there is a constant. So there is 1 missing and there is this constant. So it turns out that we can show that this constant is essentially 1. How do we do that? So if we just take, so we know of course that derivative of e power x is e power x itself. Therefore the integral of e power x has to be e power x, and one can show that this constant is essentially 1, just like we did earlier for the earlier cases. So this essentially will turn out to be e power x itself. So the integral of e power x is e power x itself. Similarly, one can do for cos x. So we can do the integration of trigonometric functions. We know that cos x is 1 minus x square divided by 2 factorial plus x power 4 divided by 4 factorial minus x power 6 divided by 6 factorial plus dot 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 up to infinity. the y, if this is my dy by dx, if cos x is my slope, this y is integral cos x. I can integrate term by term. So if I just take 1, and integral of 1 is x, integral of minus x square by 2 is minus x cube by 3 factorial, plus x power 4 will be x power 5 divided by 5, the 4 factorial will turn out to be 5 factorial, minus x power 6 by 6 factorial will become x power 7 by 7 factorial. So look, so this has become x minus x cube by 3 factorial, this has become x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial, and so on and so forth. If you look at it, you will realize that this is nothing but the expansion of sin x. So integral of cos x will be sin x, and we already know that the derivative of sin x is actually cos x. So by doing this way, we can get the derivative of the we can also do this of the trigonometric functions for each of this, for any function that you like. Similarly, one can do for sin x also. So let us assume, we know that the expansion for sin x is x minus x cube divided by 3 factorial plus x power 5 divided by 5 factorial minus x power 7 divided by 7 factorial, and so on and so forth. So if the slope is sin x, the integral of sin x will turn out to be the function. So let us integrate term by term. So if I just take the first term x, it will have x square by 2 factorial is the integral of x. If this is minus x cube divided by 3 factorial, you will have x power 5 by 5 factorial. If you have x power 7 by 7 factorial as the function, its integral will turn out to be x power, x has x square by 2 factorial, x cube by 3 factorial has x power 4 by 4 factorial, x power 5 by 5 factorial has x power 6 by 6 factorial, x power 7 by 7 factorial has integral x power 8 divided by 8 factorial plus dot 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 and finally a constant. So if you do this, you will see that this is minus cos x, and this you will have a 1 coming from this constant. So to do this, let us just do this slowly. Let us understand that minus part a little bit carefully. So let us look at this function sin x, which is our y, which is nothing but x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus dot dot dot. Now integral of x is x square by 2, which is nothing but 2 factorial, minus integral of x cube is x power 4 by 4 times 3 factorial will become 4 factorial. X power 4 by 4 is the integral, 4 times 3 factorial is 4 factorial, plus x power 5 will have an integral x power 6. If I integrate x power 5, I will get x power 6. X power 6 divided by 6 times 5 factorial, it will turn out to be 6 factorial, minus x power 8 divided by 8 factorial plus dot 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 plus a constant. Now if we look at term by term, this term come with a plus sign, this term come with a minus sign, and if this c becomes 1, then this will essentially become 1 plus x square by 2 factorial minus x power 4 by 4 factorial, and this will turn out to be minus 1, because this you want to, the answer will be a minus cos x. So you will have basically minus 1 as the constant, minus 1 plus x square by 2 factorial minus x power 4 by 4 factorial plus x power 6 by 6 factorial plus dot dot dot, and this will turn out to be nothing but minus cos x. So I urge you to look at it and you will see that this is indeed minus cos x. So to summarize, what we learned so far is basically essentially a rule that one should remember while integrating. The rule is that if the slope dy by dx, which is our m, is x power n, then y will be x power n plus 1 divided by n plus 1. And if there is a constant, if m is kx power n, then y will become kx power n plus 1 divided by n plus 1. If we apply this rule to different functions, you can calculate essentially integrals using this formula for many functions, many simple functions. So with this, we will stop this lecture and continue later.